Hi there, welcome to edupediaworld.com. You're watching the videos on quadrilaterals. So in this video we'll discuss one more condition which is very important from the exam point of view to prove that the quadrilateral is a parallelogram. So you have to watch this video very carefully. Okay, so let's discuss the theorem, how we can prove that now. The theorem says that a quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. So what does means is, let's say first we draw the quadrilateral. So let's say we have a quadrilateral like this: A, B, C, D, A, B, C, and D, and let's say we have one side equal and parallel. So let's say first what we need to write is given. So it's given that ABCD is a quadrilateral, right? And it's given that AB equals to CD and AB is parallel to CD. Now we need to prove that the quadrilateral is a parallelogram if pair of opposite sides is equal and parallel. So which means that we need to prove that this side equals to this side and this side is also parallel to this side. So let's discuss how we can do this. So to prove this we need to do construction. Construction is this: let's say we draw a diagonal AC. Okay, so we draw a diagonal AC. Now let's consider triangle ADC and triangle ABC. So we have two triangles now. So let's prove this triangle is congruent. So we can say that first this angle equals to this angle and this side are equal, it's given, and this side is common. So these two triangles are congruent by SAS. So let's write it now. So we can say that angle ACD equals to angle CAB. Why? They are alternate angles. They are alternate angles, and it's given CD equals to AB, which is given, and AC equals to AC, which is a common side, So we have three conditions: 1, 2, and 3. So we can say that triangle ADC is congruent to triangle ABC by SAS. So we can say that now AD equals to BC and AD is parallel to BC by CPCT. So which proves that in a quadrilateral, if the pair of sides are equal and parallel, so it's a parallelogram. So this becomes a parallelogram. So we can say that now ABCD is a parallelogram. So this is how we can prove the theorem. So let's discuss one example related to this theorem, so which is very important example from the exam point of view. So you have to watch it very carefully. Now the example says that ABCD is a parallelogram in which P and Q, means this point and this point, are the midpoints. So we can say that this equals to this and this equals to this of ABCD. Then now AQ intersects DP, okay, and at S, and BQ intersects CP at R. So these are the point. So first we need to prove is APCQ is a parallelogram. So we need to prove these three. So let's discuss how we can do this. So first we need to write given. It's given that P and Q are the midpoints. So we can say that AP equals to PB and DQ equals to QC. So let's discuss how we can prove this now. So first part we need to prove is APCQ is a parallelogram. So let's discuss how we can do this. So we need to prove that this quadrilateral is a parallelogram. So we need to prove this. Now it's given that AP P is a midpoint. So we can write AP as half of AB and we can also write QC as half of CD, and it's given that AB equals to CD. So we can say that we can write AB as 2AP and CD as 2QC. So this get cancelled. So AP equals to QC, and since ABCD is a parallelogram, so we can also write AB is parallel to CD. So we can also say that AP is parallel to QC. Now one pair of sides are equal and parallel, so it's a parallelogram. So we can say that now APCQ is a parallelogram. So this is the first part. We can prove this. Now let's discuss the second part. We need to prove that DPBQ is a parallelogram. So let me use another pen. So we need to prove that this is a parallelogram. So same way we can prove that. So since P is a midpoint, so we can write PB is half of AB, and we can write DQ is also half of CD. So since AB equals to CD, so we can write 2 times PB equals to 2 times DQ. So in this 2 and 2 get cancelled. So PB equals to DQ. Since it's also given that AB is parallel to CD, so we can write PB is also parallel to DQ. So again, one pair of opposite sides are equal and parallel, so it's a parallelogram. So we can say that DPBQ is a parallelogram. So this is how we can prove the second part. So this was the first part. Now let's discuss the last part, which is the third part. So it's also very interesting. So for the third part, we need to prove that PSQR is a parallelogram. So this means this part is a parallelogram. So we need to prove that. Now since we have proved that DPBQ is a parallelogram, so we have proved that already. Now if you see properly, SP is a part of DP, okay, and QR is also part of QB, right? Since DPBQ is a parallelogram and since DP is parallel to QB and DP is also parallel to QB, so we can say that SP is also parallel to QR. Similarly, if you see this one, now let's discuss. Now it's all we have already proved that APCQ is a parallelogram, right? Then we can see clearly that SQ is a part of AQ, and we can see clearly now PR is a part of PC. You can see. So if AQ is parallel to PC, then we can also say that SQ is also parallel to PR. Now so let's write it over here. So SQ is also parallel to PR. Now pair of opposite sides are parallel, so it's a parallelogram. So we can say that now PSQR is a parallelogram. So this is how we can prove these type of questions. So thank you once again for watching this video on edupediaworld.com. Keep watching further videos. Have a nice day.